Problem 28. I think today's section is the last section in this chapter, so.
I'm missing a page.
So everyone around the test is?
Yeah.
No, Wednesday or Tuesday?
28 says, let's see. Find the probability of A or B or C for the given probabilities.
Do you have an extra book? I think there's my book in there.
Might be one up there.
Well, I think it. Yeah.
Can you reach it?
Okay.
So right above, they give you a formula up there. It says the addition rule for 3 events, the addition rule for the probability that the event A or B or C. And they give you a formula up there. And that formula says probability of A plus probability of B plus the probability of C minus probability of A and B minus, I don't really want to write it underneath. I'm going to go downhill, so just stick with me. Probability of A and C minus probability of B and C plus probability A and B and C. Now that would be really, really, really confusing, except for the fact that they gave you all those. Somebody help me out, what they tell us the probability of A was, so I don't have to keep looking back in the book.
0.40,
Probability of B,
0.10,
C,
0.50.
and that should be the case if we look at this. There's only 3 events that could occur, right? So all 3 of those should add up to be how much? One whole, 100%, whatever, so that adds up to that. And I believe they told us what's the probability of A and B.
0.05.
Probability of A and C.
0.25.
Probability of B and C.
0.10.
And the probability of A and B and C.
0.03.
And all we're gonna do is, that's 100, minus that, that'd be 0.95, minus that would be 0.70, minus that would be 0.60, plus that would be 0.63. That should be our answer. So 63% chance that, I gotta go back and look at the problem, see what it said. 63% chance that we get A or B or C, which that makes very little sense. Because if we get A or B or C, those are the only 3 things happening, what should the percentage be? Should be 100 if those are the only, there must be something else in there that. But according to the way this looks,
It's 100.
that looks like those are the only 3 percentages. Sure we didn't write anything wrong or anything, I don't think so. Well, that's the answer. Doesn't make much sense though, because it seems to me that that should be 100%. Other questions?
21.
Education. Says the number of responses to a survey are shown in the Pareto chart. What's a Pareto chart again?
Where it goes.
They go from,
Largest to
The survey asked 1,026 U.S. adults how they would grade the quality of public schools in the United States. Each person gave one response. Find each probability. Sorry, I got lost there for a minute. Pareto charts. If I was a school or the state doing this chart, I sure would not put this in a Pareto chart, because we look over to the right and you see that 52 said that the schools get an A, right? Well, as soon as you look over there to the right, what do you think's on the, what would you think is on the left? If A's are on the right? F's. And that's what people look at it and go, 335 people said they got F's. No, that's not the case. It's 335 said that they give it an average, a C rating, but that's what it looks like. Part A says randomly selecting a person from the sample who did not give public schools an A. So we want to get the probability not an A. Probably going to be easiest if we find the probability of what?
Of A,
Of an A. How many people gave schools an A?
52,
Out of?
1,006.
Somebody divide that for us, give us a decimal.
0.05.
These two, does anybody remember what are these two events called? Think of geometry.
Complementary.
They're complements of each other. So what do we do to find this one? What can you do with this answer to find this answer?
use the opposite.
Subtract it from 100 or 1.0, so it's 0.95. So 95% of the people did not give schools an A. Again, because that looks bad, and this always drives me nuts, and I probably told some of you, since I've had you in class a couple of times, when mommy and daddy's yelling at you for not getting all A's and B's, should you get all A's and B's?
C is technically your average.
Right, C means you're average.
You could still be on the principal value on that.
It makes no sense to me why anybody's parent would think so much of themselves and their kids that if they get a C, they're mad at them. So you think so highly of yourself and your family that your kid cannot be average. Well, that's
So that's my mom and dad's who barely passed high school, and they still think.
see, and I would tell George the same
Yeah, he
thing.
barely passed high school, but he gets on me for
I would tell him the same thing if I talked to him about it.
only.
That means that they're average, that,
Yeah, my brother barely passed high school, so they don't really hold me to this.
I try to
super high standard.
tell my son all the time up at Eastern Michigan taking, when he was taking engineering courses and getting C's, and he's all upset with himself, and I'm like,
You're passing.
90% of the people in this country could not take that course, let alone get a C in it and be average in it. Part B.
Do you get the, percent for each? Can you do that?
Do I?
For part B?
I haven't read it yet. Randomly selecting a person from the sample who gave the public schools a D or an F.
Are you able to do that, like add them together? Or?
Yeah, so I was trying to think of another way that we could do it. So what we're gonna do, we want a probability that you get a D or an F. All we're gonna do is find
D is,
probability that you get a D plus the probability that you get an F. Now you gotta be careful here. This is where, when we went over this, are these mutually exclusive events? Can they happen at the same time?
No.
No. So we don't have to worry about subtracting off anything here. So we just find those. So now go ahead.
it's 0.26 for D and 0.12 for.
And then we just add those two and we get 0.38.
So that would just be the answer?
That's the answer. Book actually has, did you round those off a little bit?
Oh, no, I didn't round.
I mean, you round them off,
Oh,
because they didn't round them off that much, because they had
Did you just take the first two numbers?
388.
Or did you only get two?
If you know you're going to be adding like this, you might want to wait to round until you get to the final answer. That way you're a little closer, because, you know, if we rounded here, if I rounded after that, my answer would be 0.39, and if you come up with 0.38, I don't know if I'd take off a point or not, might. Depends how I feel that day. And if it's Michael's paper, then those definitely.
Hey, I need the extra.
That affects me, how? Other questions?
Where's the number 9?
Number 9. Number 9. Decide if the events are mutually exclusive. Explain your reasoning. Number 9 says randomly select a female public school teacher. So we want probability that you get a female teacher. And then B is randomly select a public school teacher who is 25 years old. So a 25-year-old teacher. Are they mutually exclusive? Can they both happen at the same time or not? Yeah, they could happen at the same time, so they are not mutually exclusive.
So mutually exclusive is, it can't happen.
Right. So that means if we were finding these probabilities, we'd have to add those two probabilities. And then at the end, we'd have to subtract off when they both happen.
So if something is mutually exclusive, that means
They can't have it.
they can have
It
it?
can't, cannot. So if we're drawing a name from a hat, and I say, I want to draw a male or a female, can those events happen at the same time?
Well,
No.
you can't pull a male and female.
So that'd be no. So those are mutually exclusive, because they can't happen. So if I had
Oh,
that.
okay, so like since you can, you have to subtract something, that means they're not.
Right.
Facts.
So if it was male, female, the circles, and maybe this would help you, Jen, if you sort of draw it something like this. These two cannot happen at the same time. The circles wouldn't touch. Okay? If I said I wanted to draw a male or Cody. So Cody would fall in there, that could happen at the same time. And then that would make them not mutually exclusive. Or if you're looking at the, like for this one, if I got a female teacher, so these are female teachers, and then I have another circle for teachers who are 25 years old. Well, there's going to be some of those females that fall into both those categories. So those could, that's when they could happen at the same time. Other questions? Let's see. A math conference has attendance of 4,950 people. Of those, 2,110 are college professors. 2,575 are female. Of the college professors, 960 are female. I'm looking at those. Let's see, that's 4,685 plus another 1,000. It's 5,600 and some. So they said there was 4,950 people at this
That's what I thought
conference.
when I read it, the numbers.
Yeah, that doesn't make sense.
So it doesn't, it seems like there's too many people, isn't it?
Yeah.
Yeah.
Why is there too many people though?
I don't know.
What we were just talking about.
Oh, they overlap.
They overlap. So is there really too many people?
No, it's just how they word it. Getting confused.
So some of these events are not mutually exclusive. Are the events selecting a female and selecting a college professor mutually exclusive? So, I'm not gonna let Isaac answer this because he's a sexist.
Don't let me answer either then.
Is there, don't make me go down and ask Miss Martin to come down. Is there a chance, I was recording that. Is there a chance that when we draw that name, that they're a professor and female?
Yeah.
Yeah.
Oh,
Yeah.
yeah, ask her, yeah.
So these are not
Don't get me started.
mutually exclusive, because they could both happen. The conference selects a person at random to win a prize. Find the probability that a selected person is female or a college professor. So we have probability that they're female or college professor. Well, we're gonna have to add those two probabilities, but you just told me what's true about those two probabilities.
They're not mutually exclusive.
So that means we're gonna have to subtract off
Whatever.
when they are female and a professor at the same time. So we need to find all three of those probabilities. What's probability?
What is that, what equation that you're using, what's that called?
This
Yeah.
addition rule. What's probability that a female is selected? How many total people were at the thing?
It was,
2,500. Are we using the 4,000 one or like
Yeah, I mean,
how they
'cause-
added?
yeah, don't be a sexist now, Riley.
4,950.
Don't leave the males out.
2,500 and something.
Yeah.
I thought we were doing something.
4,950,
Oh.
950, right? Don't be trying
Where
that.
did we get the extra people from then?
There is no extra people.
There's males.
They just overlap.
Oh, they just didn't do the males in
Yeah,
there?
they're overlapping.
Wait, what
The
is
males, yes, Riley, the males are allowed to win the prize too. Don't
Well, I
be
get
trying to.
that.
What's the 2,000 number? I don't understand what that is. On What's that is?
Those two.
Which 2,000?
Okay.
It says,
Like, I just-
of these 2,110 college professors.
So 2,110 are college professors. And then it says, and 2,575 are females. So, we want the females. What's gonna go on top here? How many females are there at this thing? 2,575. Plus, then we want the probability that it's a
Oh,
professor.
so that's where the 2,000.
That's still 4,950 on bottom, right?
But that's
Yeah,
2,000.
2,000.
Okay, that makes sense.
Now again, why we're subtracting something off is because could these two overlap?
Yeah. So then we put how many times they.
And that's what we, oops, I don't know why I put a P there. On bottom, it's gonna be 4,950 still, ignore the P. How many female professors are there at this conference? What is it? 960?
Wait, how do you find
It says it. It's right there. It says of college professors are female.
it? Oh, okay.
Now, they didn't ask you this. Could we figure out, from the information they gave us, could we figure out how many of the college professors are males?
Yeah.
Yeah, if we got this many college professors, this many of them are females, we just subtract those two if we needed the male number. This was professors. We could find out how many of the total people are not professors at all, just people that are there for whatever, and join it because it's a math conference.
Just hanging out.
What do we do with all these?
Just add them to the
Add those two, subtract that one, your bottom number's still gonna be what?
4,000.
That's gonna be the same, what's on top? Didn't I just give you batteries? If I just gave you batteries, I sure don't wanna hear a lot.
3,725.
And then what are we gonna do with that? Somebody give me the decimal. Probably on these decimals, we probably need to start going out 3 places maybe.
0.752.
752?
You always want us to go out 3 places?
Yeah, it'd probably just be easier that
You
way.
need batteries for my calculator, not my energy.
That annoys me because
Both of them are 725.
I don't want to do that.
Me either.
All right,
Crash the ball.
couple of things on this.
I was a little lost.
Grab this that you got from last time.
Yeah, facts. I don't know.
Oh, it's time for me to go.
We're going to go over the notes and stuff for this, but I just want to go over a few to show you.
Is this gonna be on the test of the permit?
Yeah. So P, this P, and you're gonna have to make sure you don't get this confused next time we take another symbols test or something. Permutations is another P. So you got probability. Probability always looks like this. Then you got percentiles, which looks something like this. And then you got permutations. So don't get the P's confused. With this, I'm hoping that when you look this up on the notes, it's not all that difficult. Takes a little work. That's probably why somebody's saying it was difficult.
It wasn't me.
The formula just looks like this. N factorial over N minus R factorial. Go ahead, you're right.
So that's always the thing? Like
For
always?
permutations. This is always N. That's always R.
What class have we done this before?
Geometry.
Sounds like it.
Sounds
Seems familiar.
The N always has to be bigger than the R because what you're doing with permutations is you're saying, I want to pick this many items, the second number, out of this many items. Well, if you turn that around and did this, and you said, I want to pick 7 items out of 4, that doesn't work. So this number always has to, n always has to be the bigger number. When you do this, it's just going to be 7 factorial on top. On bottom, it's going to be 7, and you don't have to write all of this out every single time. 7 minus 4 factorial.
Where's the, I can't, where's that on my
I'm not going to tell you.
We gotta figure it out.
Now, once we have that, 7 factorial means this. 7 times 6 times 5 times 4 times 3 times 2 times 1. It means that number multiplied by every other number all the way down to 1.
That's what that, okay.
That's what that
So
exclamation mark
that's how I'm
means.
gonna have to do that? Oh, I'm gonna mess
7 minus 4. What is 7 minus 4?
up. 3.
So we get 3 factorial, which means 3 times 2 times 1.
Okay, so that's,
Every time this happens, this is what, when you're doing permutations, this is what's going to happen. You got 3, 2, and 1 down here, you got 3, 2, and 1 down here, what can you do with them?
Cancel out.
So you just do 7.
So all you're doing is 7 times 6 times 5 times 4.
Yeah, I didn't mess up.
And you punch that into your calculator.
so we couldn't do it like the way you.
Oh yeah, you could, but I'm not going to tell you how yet.
You're confusing me.
Don't even lie to me, you just want to use the
I
calculator.
do, but
You
I'm,
can handle
no,
that.
I'm confused.
Oh,
Like,
you're
I
right.
couldn't type all that in, like figure out both,
Oh yeah, you could. I don't know why you'd want to.
because you can't put too many steps in
Oh,
my
I
head.
found it.
Weird.
We have different calculators.
So we got
Let me see what
this 20, that's 120, 120, what is that, 840? Is that right?
Yeah.
Yeah, wait.
All that's telling you, when we're doing this stuff, when we're doing permutations, this is telling you the total. So when we're doing a probability, that's going to be the number that goes on the bottom of a probability. That's how many total possible outcomes there are.
Well, wait, the bottom's 4. Shouldn't you have to have
Oh, I
4
found it.
times?
3. No, we subtracted the 7.
Oh. Sorry. I told you, I don't know what to do. I got it.
So pick another one.
Wait.
Can we do number 3?
Yeah, I want to do number 2 first,
Okay,
because I like it.
okay, you're good.
Number 2, they give us this. We got 10 items, and we're trying to pick 3 of them at a time. And we want to know how many different ways out of those 10 items can we pick 3 items. So again, on top, it's going to be 10 factorial. On bottom, it's going to be 10 minus 3 factorial. We'll try to help Jen out here so that she doesn't get confused too much.
I got it now.
Because you really don't have to do all those steps that I did there. You could probably look at this and say 10 minus 3 is 7. So you have 7. You have 7 factorial on bottom. Well, when you go to write it out, we know that it's going to be 10 times 9 times 8. And then I'm going to stop there because the rest of it's just going to be 7 all the way down. Well, on bottom, we got 7 all the way down. What's going to happen with all those numbers? So all we really have is 10 times 9 times 8.
700.
That's our bottom number. If this is the total possible outcomes. So what permutations are, if I took these 10 books right here, I have 10 books, and I want to pick 3 of them. All right? There's 720 different ways I could take out 3 of these books. That's what it's saying. All right, so I could pick 43, 31, and 49. I could have picked 43, 31, and 38. Make sure you're counting these, and when I get to 720, we'll know we're done. 43, 31, and 20.
That's 3.
All right, but that's what it's saying. I could take out those books. Now, with permutations, and when we get to the notes, I'll explain this more. With permutations, I always don't know how to say this because it confuses everybody no matter which way I say it. If I take, with permutations, if I take 43, 31, and 49, that's different than taking 49, 31, and 43. So if I take them backwards, that's a different permutation.
It's like the order you take.
Right, so when I'm dealing with permutations, the main thing that I say anytime with permutations to help you remember this, it's a race. Right? A race is like a permutation because Lily, Michael, and Isaac could finish the race 1, 2, 3. Does the order that I put them in matter for something?
Yes.
Yes.
Yeah, because you want to win. You want to be first. So permutations are like it's a race. So these books sitting over here on this shelf, they want me to pick them first. So if I pick 43, 31, 49, 43 is happy because he got picked first. All right? If I pick 49, 31, 43, now 43 is mad because I picked 49. I like it better. That's a permutation where when you switch around that order, it's a different setup. It's a different permutation. Now, when you do this in, Lily said she wanted to see this one. When you do this, it shows you something different. So 4 factorial on top, then on bottom it's 4 minus 4 factorial. A math rule here before we go into this so you can see where this stuff comes from. Because everything in math is a pattern, and you got to make sure that you're keeping things in that pattern. What's 3 factorial? What is that?
6.
What's 2 factorial?
2.
Let's do 4 factorial. What's it?
24.
You might see a pattern here. Probably should have did more. Let me move my thing up here. Want to help me out? What's 5 factorial?
I do too, Joe.
5 times 4 times
120.
120. What's 1 factorial?
0. Oh, 1.
Wait,
It's on pre.
I'm lost.
It's not math.
It's on pre.
I'm lost.
Nobody seeing a pattern?
Pro.
It goes.
PRV.
Oh. Yeah.
1, 2,
Like-
6, 20.
Oh, yeah,
Six.
PRV.
24, 24, 120.
Yeah. 6
No.
times
120.
I'm not seeing one.
4 times 24.
And 2 times 3, and then 3 times,
1 times it's 1 times 2. I don't know.
Every one, look. So if I take this, I got 5 factorial here and I got 120. How am I going to get to here?
Divide by 4. Oh.
Divide by
5.
divide by 5. How do I go from here to here?
6.
4.
Divide by 4. How do I go from here to here? Divide by 3. How do I go from here to here? Divide by 2. So on the next one, I should be taking this number and I should be dividing it by what?
C1. 1.
What's 1 divided by 1?
1.
And it has to be a pattern. And I see the look on Riley's face like,
Why is 0?
oh, why is 0, 1? Because for this to make sense mathematically, we have to keep it in that pattern. Okay? So it has to go in some pattern, and that's the pattern. So when we
0 will always be 1.
so when we have 0 factorial on the bottom here, 0 factorial is always 1. And then you don't do negatives factorial, so we don't worry about that. So that's always just going to be 1. 4 factorial, you guys just told me is 24. What's 24 divided by 1? But 0 factorial is always 1. Combinations. Combinations is a little different. That's the C. Jump down to number 5 real quick.
I have a question for you. So you know what to tell us. So is C on the calculator?
Huh?
Is C on the calculator?
I'm not telling you.
Oh, sorry.
Wait, there's a P on
Yeah,
the calculator?
there is. I found it.
Math?
When we do this, watch closely so you understand
I
this.
don't know how to type
I,
it in together.
I think on the test I'm going to make you do them all out longhand now.
Okay, we definitely did this before then, right? Because I swear that sounds so familiar.
When we do combinations, the difference with combinations. When I go over here and take these books and I take 43, 31, and 49, they're all happy. They don't care which one I took first, which one I took second, which one I took third. They're just all happy that I chose them.
So it's like a participation race.
Exactly. They're all just ecstatic that they get to get picked and pulled off the shelf. Right? So another thing. If I put all your guys' name in the hats to tell the difference between permutation and combination. I put all your guys' name in the hat, and I say, I'm going to draw out 3 names. The first name I'm going to give $10 to. The second name I'm going to give $5 to. The third name I'm going to give $1 to. Do you care where your name is drawn?
Yes. Yeah.
That's a permutation.
You want $10.
Now, if I said I'm going to give $5 to all 3 names that I draw, do you care if your name's drawn first?
No.
No. Now, you probably want your name drawn first just so you know you won right away and you don't have to worry about the other 2 draws. But it doesn't make any difference which one your name is drawn. That's a combination. The formula for combinations looks like this. Again, this is in, that's on top, factorial. On bottom, it's sort of the same. It's this number minus this number, factorial, times, then you got to take this number, factorial again.
So that's the R.
That's the R. This is N, that's R. When we do this, the reason for this, there's going to be fewer combinations than there are permutations, because now when we go Lily, Michael, Isaac, that's the same as going Isaac, Michael, Lily. So we don't want to count both of those. That's a combination, because we don't want to count them all over again. That's what this part does. It gets rid of all those ones that are repeated.
So if you have a combination and the answer comes out to like 720, like number 2, you know it's wrong because there's no 10.
Well, it could be that high, but so our permutation for this one was 720, right? The permutations for this are 720. The combinations better be lower than that if it's the same N and R. So this is 7 factorial, which means 7 times 6 times 5 times 4 times 3 times 2 times 1. On bottom, 7 minus 4 is 3, right?
Yeah.
So we got 3 factorial, which is 3 times 2 times 1, times 4 factorial means 4 times 3 times 2, ignore that, times 1. Now, when I'm doing these problems, if I'm doing them out longhand like this, and normally I do them longhand because I don't feel like grabbing my calculator, those will all cancel out. Then I look at these numbers. 3 times 2 is what?
6.
I get rid of those. What's the only thing I have left?
7 times 5.
So what's 7 times 5?
35.
35 over 1 is just
35.
So if I got 7 items here,
Oh my gosh.
I got my 7 items there, and I'm doing a permutation. I'm picking 3 of them and aligning them down here. There's 720 different permutations. 720 different ways I could pick 3 and line them up down here. If I'm doing a combination, there's only 35 different ways that I could take 3 of these at a time. Because the order doesn't make any difference. So if this is A and this is B and this is C,
We can have C.
ABC, CBA, BAC, those are all the same if it's a combination. If it's a permutation,
And that.
then ABC is different than BAC. And those are 2 different permutations. Again, if we're finding probability, that's going to be our bottom number of our probability, then we got to figure out the favorable outcomes out of that on top, whatever happens to be whatever we're dealing with. Looking at the backside real quick before we move on to these notes.
Are we gonna have a study guide?
Do what?
Are we gonna have a study guide?
Yeah. Let's see here, a team of 8 basketball players, number 1 on the back, need to choose a captain and a co-captain. Permutations or combinations?
Permutation.
Permutations. All right, why?
Because it matters.
It matters. You want to be captain, you don't want to be co-captain and have to listen to the other person tell you what to do. Number 2, Rob and Mary are planning trips to 9 countries this year. There are 13 countries they would like to visit. They are deciding which countries to skip. Because whatever 9 countries.
Specific ones.
Let's see, whatever 9 countries they're going to, does the order really make a difference?
No.
Now, it probably should, because, I mean, if you're in the United States and you're going to go to Canada and you're going to go to France, you probably should go to Canada before you go to France because it's closer. But if you're going to 9 countries this year, you probably don't much care about money. Number 3, batting order of 7 players on a 12-person team. Permutation. Jenna knows she likes that number 9 spot.
With that
Yeah.
.058 average.
There are 45 applicants for 3 computer program positions.
Permutation.
Combination.
If these 3 jobs, it's combinations. If these 3 jobs are open, you care if they pick you first, second, or third?
No, you just want the
As
job.
long as you get the job.
So it's a combination.
So it's a combination. Number 5, and all we're going to do on these other ones is just tell whether it's a permutation or a combination. Castle and Joe are planning trips to 3 countries this year. Right away, which one is it? Combinations. And we just did that one up there, it's just a different thing. There are 110 people at a meeting. They each shake hands with everyone else. Are we doing permutations or combinations?
Combination.
I don't know which.
Doesn't matter.
So
Well,
if,
you don't want to count people's plays.
so if Michael shakes hands with Isaac, this is the way you sometimes you gotta think about it. Is Isaac then gonna go back and shake hands with
No.
Michael? No, that's already took care of that, so combination. You're setting the combination, boy, this one gets a lot of people. You're setting the combination on a 3-digit lock. You want to use the numbers 1, 2, 3, but don't care what order they are in. Permutations or combinations?
Combination. Permutation.
It's a permutation, because when I
I
said,
call it a locker combination.
Well, why does it say they don't care what the order is?
Because
Oh,
there could
because
be
then when you
multiple.
set the order, it's set.
so when they do this, 1, 2, 3, that's still a win for this person, whoever this goofball is, it wants 1, 2, 3 for whatever reason. But is it different than
Yeah.
2, 1, 3?
Yeah.
Yeah, it's a different combination.
Why would,
So-
why would they call them locker?
Do we really want to go there and confuse people more than we have to?
They're called locker combinations.
She just won't give up on it. What she wants everybody to be confused. She's just going to keep. A group of 25 people are going to run a race right away. That tells you what? Permutations. Unless it's some stupid race where, oh Michael, you're so great. Even though you finished 25th, you're the greatest runner ever, and they give you the nice participation.
That crap's so stupid.
That's
One trophy that says like
Try.
participated in
I'm
it.
not doing traffic.
Just go slow.
Actually, I kind of have to.
You know, so stupid.
At least we did
Who's
this.
proud to have
And it's us.
a
We
trophy
got a
that says
trophy
you
just
got
like
like
everyone else
15?
got.
But it's not like people
I mean, it
do
really
practice.
depends, guys. If there's like 300 people, I'd
No,
probably
that's stupid stuff.
I used to have a lot of trophies, but me and my brother used to throw them at each other when we were younger, so all of them are broke.
That's stupid.
I used to throw Taylor's. I got in trouble once because I broke, I think, like 4
They're
or 5 of
hefty.
them.
They're good weapons.
I really got.
I broke a lot of Taylor's. I was throwing at them.
Permutations and combinations. I don't know if you wrote this down last time or not, but whatever you did write down, you might want to write down now. Test won't be next class. Test will actually be after break, but it'll be the first day we come back after break.
Wait, test won't be
Thank
next
you.
month?
You guys are saying thank you now. When we come back that day, you're going to go, oh my God, we have a test today.
I will not be that one.
Wait, so
Oh,
we're not,
wow.
why are we having a Friday?
I'll be honest with you, I'll totally
We don't
forget
have
what
this
happens.
I say we just take it Thursday, cause you're gonna have me freshed up, and I'm gonna totally forget.
You really want to take a Thursday?
No.
No.
I do.
I want to have time to study.
You're
Dang,
gonna
well, I
study
did was
over
study.
break? Yeah, I'm not studying.
If you have free time on Friday and you wanted to come in and take it, I'd let you.
Okay,
I got free time on Friday. Come on.
So permutation is an ordered arrangement of objects. Again, because I confuse everybody every time I say it. But the order that you put something in,
Matters.
Matt, see, I hate saying it that way, because then when I get to the combinations definition, it's gonna say sort of the same thing. The order matters, so don't count these two, is what it's. So you just gotta understand that 1, 2, 3 is different than 3, 2, 1. It's different. That's what a permutation is. In factorial, that exclamation mark is a factorial. Hint, hint about the next symbols test. So
Who's back?
it's factorial. I didn't get them back.
No.
Oh.
Oh, that's right, I wasn't here. Yeah, I got them back here. I'll hand them back. So it's a factorial, and it just means that you take the number, whatever that number is, out times every other number all the way down to 1. Please don't. Somebody last year, I think, in here took it all the way down to 0 every time, or 1 and 2. If you took it down to 0 every time, what would your answer be? 0.
Like something Kim Pearson would
So 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. Factorial. This factorial actually is sort of like the fundamental counting principle. That's, if we're doing something out, that's sort of the same setup. You're just multiplying that out all the way down to 1. So that's permutations. The objective of a 9x9 Sudoku number puzzle is to fill the grid so that each row, each column, and each 3x3 grid contains the digits 1 to 9. How many different ways can the first row of a blank 9x9 Sudoku grid be filled? So the first row, I'm guessing they're saying that this is the first row right there. How many choices do you have for the first thing here?
9,
How many for the second one?
8, 7, 6, 5, 4, 3, 2, 1.
And that's just, all it is 9 It's just 9 factorial. And that comes out to be 362,880 different ways.
That's a lot of ways.
A lot of different ways. That's just the first row.
And then I don't really like know how to do it. Like, so say you would go to like column, like the 8 column, you can't.
If we did this column, it'd have to be 8, 7, 6.
5, 4, 3, 2, 1.
And then this column can't have another 8 in it, so it'd have to be like 9, 7, so on, so on.
But that row can't have.
Yeah, I
two
can't.
screens.
So that's where it starts getting confusing.
Don't ever play that game.
Again, this is factorial.
If you remember the number and something, you'll put it in there.
Make sure you know factorial on your calculator here, I'll tell you now.
I got that.
On your calculator, if you hit the math button, I could be wrong.
You're not
No,
wrong.
you're right.
You hit the math button, I think down below, what is it, like the fourth one down?
PVR, that's the final
PRB.
PRB, yeah.
Oh, you hit the math button, then you go over to PRB. Guess what PRB stands for? PRB, probability. So make sure you hit the math button, go over to probability. We're going to do a lot on that screen. You see there it's got NPR, NCR, it's got factorial. We're going to use all of those. We're also going to use the R, A, and D up there at the top at some point. And I think maybe the R, A, and D norm thing. So all of that stuff is right there on the calculator. I'll show you how to do some of it here in a minute. With the factorial, though, all you got to do, if you want to do 9 factorial, you've got to put in 9 first. Then hit the math button. Go over to that. Go down to it, and it says 9 factorial. Then you can hit enter. And it should give you that answer. Permutations of object in there. Do that. What did I do?
No,
We wrote that down, didn't we?
No.
not the, where R is greater than.
Oh, we didn't write down the formula.
Remember last time?
Oh, you showed it, like.
Yeah, I did it earlier, but I thought it was on that first slide. So that's the formula for permutations. Please don't forget the formula, because when you don't know how to do it out longhand, and you punch it into your calculator, you have no idea whether the calculator is telling you right or not.
Yeah, that one I got like 20,000.
Yeah, same. I was like, what the heck?
So you got to have some idea that the calculator is telling you right. You can't just punch it in there and say, oh, well, the calculator got to be right. Well, the calculator is only as smart as the operator.
We all know you can't trust.
R's always got to be less than or equal to N, so all that's saying is that N's got to be bigger than R every time. If it's not, we talked about that. Can't do it. And if you do write it out longhand, which you see, even though I know it's on my calculator, when I did this worksheet, every time I wrote out longhand. It's not that hard. Unless you're a whiner,
Yeah.
then it's hard.
You get too old for this, Mr. Ebersole?
Find the number of ways of forming 3-digit codes in which no digit is repeated. So we got to, I didn't know it was going to pop up everything. So we got a 3-digit code. Take it back here. We got a 3-digit code. So we're picking 3 numbers at a time. But how many total numbers if we're on like the lockers out here? 10. All right, it's
How
10.
do we
Like,
know how to put?
because this
They
is
always
the
pick
number
a
that
bigger
we're
number?
this is the number that we're picking from. How many total we have to pick from?
You can't pick 10 out of 3.
This is the one that we're picking. How many we're picking at a time? So we're picking 3 at a time from the 10. And our 10 is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So we pick 10 or 3 numbers. We could pick 5, 7, 4. But what this is saying is that we can't repeat. So we can't go 5, 5, 5. 5 can't be every answer. So we do the permutations. I'm just going to put it up here now. 10 factorial on top, 10 minus 3 on bottom, which is 7. From 7 on down, we just did this one, so that's going to leave us 10 times 9 times 8. And that's 720 different ways that we could make a combination. "43 race cars started the 2007 Daytona 500. How many ways can the cars finish first, second, and third?" You could do this without doing this by using the fundamental counting principle that we had earlier in this chapter. If I just look at, and this works some of the times, not all the times, but for a problem like this one it works. If I just look at first, second, and third, how many cars could win first place?
43.
How many cars could win second place?
42.
Because you just, one of them already won first, right? How many cars could win third place? And then what are we going to do with those to find the different ways? Just multiply. So that's using the fundamental counting principle. All right? We could do it that way. We could do it using permutations. We got 43 cars. We're taking them 3 at a time. We have 43 factorial on top. 43 minus 3 factorial on bottom. What is 43 minus 3? 40 factorial. So that means from 40 on down is going to cancel out. So we just got 43 times 42 times 41, which that's what we just said up here. And we come up with 74,046 different ways that race could have ended. And this is what I was just saying, the fundamental counting principle, you can use that, like if you got real big, huge numbers. If we're doing the lottery, and there's like 60 numbers or 65 numbers in the lottery now, and you don't want to do 65 factorial and all that stuff, well, if there's 6 numbers in the lottery, 3, 4, 5, 6, how many choices are there for the first number? There's 65 balls and ping pong balls, and then for the second number? And you could multiply all those together to find out how many total possible outcomes there are. Example, if we pick 3 students from our class, if I'm just going to pick 3 students, how many of you are there in here? 9. I'm not sure why it switched back on me. So there's only, is there 8? 8. So we got 8. That's, I could pick 8 of you at first, times 7 of you the second pick, times 6 of you the third pick, multiply those together. That's how many different ways I could pick it. Was that 42, about 3,200 and something. This is a little tougher. Distinguishable. Make sure you write this down. I'll give you a second. Distinguishable permutations. Confuse people sometimes. What it means by distinguishable is you don't want the same thing to occur. So, if I'm picking letters out of a hat, and there's 2 A's and 2 B's in there, and I pick A first one time, and then another time I pick A first, that's the same thing, even if it's a different A. All right, so that's what distinguishable is, and that's why the formula changes. don't make this harder than it is. It's not all that difficult. It's just saying if I'm taking these numbers down here, and maybe I want to pick 3 of them, and I pick 2, 2, 2 the first time, then I pick 2, 2, 2 the second time, those aren't distinguishable. We can't tell them apart. So we're going to get rid of that one. 2, 2, 2 is the same as 2, 2, 2, no matter which order the 2's went in. All right?
So,
I'm gonna explain it here. Go ahead and write, Jen. I'm gonna explain it. Don't make this formula any harder than it is. It's not. It's sort of the same formula, it's just a little different.
You told me what?
How many numbers do I have down here in my list? 12. So we're picking from 12. Make up something. How many numbers do we want to pick at a time? 4. 7. 1 of them, it doesn't matter. So if we're doing it this way, we're doing 12, and we're taking them 4 at a time. What's going to happen? I'm going to get rid of that because that's probably going to confuse somebody. All you're going to do is this. How many numbers, total numbers you have? We said 12, right? So that's 12 factorial on top. So that we get rid of the repeaters, the extra ones, the 2, 2, 2, and the ones that are the same, and we can't tell if we actually pick something different or not. All you got to do is this right here. We look at this. How many 2's are there? 4. So we do 4 factorial on bottom.
Oh, that makes a lot of sense.
Times, how many 4's are there? 1. So we do 1 factorial on bottom. How many 5's are there?
2.
So we do 2 factorial.
So that's when it gives us a set, like it'll give us that set?
Right.
Oh, okay.
And then
How many 6's?
1.
So we do 1 factorial. How many 7's? 3 factorial. Sorry, that's ugly.
1, 8.
I ran out of space. 1 factorial again, right?
Yep.
Now the 1 factorials, we really don't need to even write them in there. Because 1 factorial is just 1. That's not going to change anything. So if the number only is in there only once, you don't really have to worry about it. It's the numbers that appear more than once or whatever that appears more than once that matters. No, you probably shouldn't. Because you see, like I ran out of space.
It's going to be 12.
So it's 12 factorial over 4 factorial times 2 factorial times 3 factorial. Now again, when I do this, I probably write out 12 times 11 times 10 times 9 times 8 times 7, and you could just grab your calculator and do it and divide it if you want, times 6 times 5 times 4 times 3 times 2 times 1. All of that. 4 factorial is 4 times 3 times 2 times 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. When I'm doing this, because I don't like big numbers, I look at stuff and try to group stuff together. I know 3 times 2 is 6. 6 times 2 is 12. All of that right there is 12. Cancels out with that.
And then that cancels out with 4.
This is 4 times 3, that's 12, but we don't want to do that because we already canceled out 12. 3 times 2 is 6. Get rid of that. 4.
Didn't even know this mark off 4 times 3 times 2.
Yeah, you could have. I guess I should have probably done that. That'd been easier, wouldn't it? So then I just multiply whatever together is left. Again, if you're doing it on your calculator, because I have this sneaky suspicion that you're probably not gonna write it out longhand like I'm saying. You're probably gonna
Well,
just grab
if
your
you have a
calculator.
you get like a huge number. Is that like, yeah, that'd be a huge number.
So it might be. So if I'm on my calculator, I'd have to do something like punch in 12, go to the math button, go over to probability, go down to factorial, put that in, and then I might hit divided by. I don't know, I probably wouldn't hit divided by. I probably just hit equals, and I get some big long number. Then you're gonna have to figure out what the bottom is, and then divide that big number by that. So I don't know, however you want to do it.
4 factorial times the bottom right
Wait,
there.
did you get the
and then
answer for that?
Get that answer and then divide it by 12 factorial. So like,
Divide it the other way, yeah.
yeah, okay.
So if I, see if I do the answer here real quick.
I think I got it right.
Let's see, so I want to divide that by, I might just hit divided by, once I got the answer, I might hit divided by, then put in 4, go back to the math button, go down to, or over to probability, down to factorial again, put in 4 factorial first, hit equals. Then I might just do this together. I know 2 factorial is 2, I know 3 factorial is 6, 2 times 6 is 12. So then I'm just gonna divide that answer by 12. So just hit divided by 12. I got 1,663,200. Did you get something different?
So wait, wouldn't you have to multiply the 4 factorial by the 12 factorial, the 12? So it'd be like 24 times 12.
Wait, but when you divided it by 12, why didn't you do the
What did I do?
or whatever that's called? That.
You know, for this, because we're just finding distinguishable permutations.
Wouldn't
We're
you
not,
do the-
we're not doing anything else.
24 times 12 and then 12 divided by whatever. 24 times 12.
I already divided by this. I divided by that first,
Oh, okay.
and then I hit divided by
That.
this
okay.
second. Because I didn't know what 24 times 12 was off the top of my head. Let's see. So if you're looking at this, you got these, if this building contractor's doing this, 12 factorial on top, there's 6 of this one, 4 of this one, 2 of that one. So we're dividing by that to see the different possible distinguishable permutations. And they get 13,860 if you go to these places where they're building houses, all in little groups and everything. That's what they do because they don't want this house and this house to look identical to each other, so they'll do one kind of house here, a different kind here, another one over here, different one here, then maybe the same kind over here, so on and so on, so that they don't all look the same.
Those communities are, where all the houses are the same. Right, it's just weird.
4-letter words made from the word statistics. How many different 4-letter words? So
Well, what if they're not real words?
that doesn't matter.
Oh, okay.
So all we're doing, how many letters are we taking at a time?
4.
And we're going to take that number and we're going to divide by. Now, when we look at this, how many S's are there?
3.
So we do 3 factorial. How many T's?
3.
3 factorial. How many A's?
1.
Do we need to write that down? I's.
2.
That's it?
You won't write the C.
Is that it?
Yeah.
Sorry, this should be 4. How many letters are in that word? That's what should be on top, not 4. We're not picking from 4 letters. We're picking 4 letters, but we're taking 10. The total letters. I was being stupid.
I was lost.
So we got 10 factorial on top. 3 factorial again is 6. 6, 2, that's 36, that's 72. If I was doing this, I'd grab my calculator and I'd do 10 factorial, get that answer, and then divide by 72.
Yeah.
Combinations, write this down real quick. It's the last thing. Combinations, again, is different because now when we take something, 3, 2, 1 is the same as 1, 2, 3. So we want to get rid of those ones that repeat, and that's where this extra R down here on the bottom comes from. If you're doing these on your calculator, you go to the math button. I'm sorry, you don't go to the math button. If we wanted to do something like 7, 4, we did that one earlier. You put in 7, then you go to the math button. You got to put in the first number, the N, first. Then you go to the math button. Go over to probability, go down to NCR, hit it, and then you put in the 4. Then hit equals. Does that make sense? So you got to put in this number, then go to the NCR, then put in the second number. See if I remember what this was.
35.
So combination's a little different. When we're doing it out longhand, you do something like that. Student advisor, 3 members. So if you're picking 3 members, 17 from 17, or picking 3 people from 17 people. So it's going to be 17C3. And we get 4,080 different ways that the positions could be filled. If it's probability, we throw a 1 in there. If you want it to be you and your 2 friends, well, there's only one way that that could happen, so it's 1 out of that number. Letters in Mississippi. Probability of spelling the word Mississippi if we pick them at random. There's only one favorable outcome. We find the total possible outcomes of switching the letters all around. And remember, to be distinguishable permutations, because there's so many I's and S's in there that if we just switched them around, that wouldn't matter. So that's where this comes from. And then do 1 out of 34,650. Big giant numbers. That's the assignment. The one other thing I wanted to show you. We did permutations 4 and 4.
Yeah.
What is it if you do combination 4 and 4?
Something lower.
0.
No, it's 20. It's like.
So we got 4 factorial on top, on bottom we got 4 minus 4 factorial, oops, yeah, factorial, times
1.
4 factorial. This is 1 here, 4 factorial is 24, right?
1.
And you end up with 24 over 24, which is 1.
I just. Yeah.
Think about it. If you got 4 items and you're taking them 4 at a time, and you don't care which order they're in when you pick them, there's only one way to pick them.